Hi everybody. In this video I'm going to show you how to solve a quadratic function by using a radical. This is just one of several methods that you can use to locate the x-intercepts of a parabola, which is the point of doing this in the first place, as I wrote over here in green. So let's go ahead and begin. You can see I have 4 examples and I'm going to break them down one at a time, and I'll explain what they mean at the very end. Okay, so here we go. The way you want to approach this is you want to think to yourself, okay, now what would I do if this power of 2 was not there? So if this was not here, I would have to divide by 3 first. Well, that's what you do first. Even though there's a power of 2, how you start does not change. So I'm going to go ahead and divide by 3. And these two 3's disappear, and I get x squared is equal to 0. Now, in algebra, there is a rule that says that the only way to undo a power of 2 is by using a radical. So a square and a square root are opposite operations of each other. So if I do this here, I must also do it right there, because that's how we keep equations balanced. So what happens is that this and this cancel. I get my x by itself, and the square root of 0 is simply 0, and that would be my answer. Now what this means is that if I were to graph this function, what I would get is I would get a parabola, and it would tap the x-axis at the origin, at 0, 0. So I have one x-intercept, and it's located at 0, 0. Okay? This 0 over here is that one right there. All right, so I have one x-intercept. Number 2, let's go ahead. Now again, you want to ask yourself, what would I do if this were not a function, this was an equation without this power of 2? So hopefully you would think, okay, I need to add 4 on both sides, and that would be the correct line of thought. Okay, only difference is that you actually do have a power of 2. So let's go ahead and we're going to add 4 on both sides. Okay, and what I get from that is now x squared is equal to 16. Now I'm in this situation again where I need to find out the value of x. This is saying, what number can you square that would produce a 16? And there are 2 possibilities, both a 4 if you square it makes a 16, and a negative 4 if you square it also makes a 16. And what that means is I need to indicate both of these numbers are my answers. Now the way to actually get that is by, once again, you have to use the radical, because that's the only thing that can undo a power of 2. So going back over here, these 2 things cancel out. I get my x. The square root of 16 is a 4, but if you remember, it's not just a 4 that makes a 16 when you square it, it's also a negative 4. And because of that, I need to write both positive and negative 4 as both of my answers. And that's a shortcut way of doing it. The longer way would be to say, oh, okay, well, I have this as one answer and this as my other answer. But that's kind of a long way, and if you don't want to take the time to write all that out, you can simply shortcut it and take all this and shrink it down to this. They mean the same thing. Okay, so what this answer means is that I have 2 x-intercepts this time. And each one is located here. So this is at 4, 0, and the other one would be at negative 4, 0. Okay? And if you want to know why they have zeros for the y coordinates, please watch my previous video. I do address this topic. All right, let's go ahead and move on to example number 3. All right, in example 3, it's getting a little bit more involved, but you start the same way you do all the equations. So you first see what you have to move over, and I have to move over this. So this negative 5 moves to the other side. They cancel out, and I get 2x squared is equal to negative 16. Now I'm pretty confident at this point, oh yeah, I know what to do. Divide by 2, and I'm in business, right? I get x squared is equal to negative 8. and then I take the square root of both sides, and that's when things have to slow down. Now, the reason it has to slow down is because of fundamentally what square roots mean. And what they mean is that you have to think about, is there a value? Is there a number that you can square that will give you a -8 or any negative value at all? Any negative value. And it turns out there is no such number. So as an example, I'm going to make this, let's say we just make this -9, okay, for the sake of argument. So forget that. I'm going to zoom in real close so we don't see that -8 there. The purpose of taking the square root is to see what value you can square to give you the number under the square root. I'm going to go back there again, okay? So if, for example, I think to myself, is there a number I can square that would give me a negative anything? And I'm going to make this, you know what? Let's make this just a regular letter A. Is there a number? Anything. And if I try, and I say, well, okay, I can square A, it doesn't work because A squared is A times A, and that makes positive A, not negative A. So that doesn't work. If I try negative A, well, that's going to be positive A again, and that still doesn't work. So there is no value which can be squared that will give you a negative answer. And for that reason, when we go back and look at what we actually have, this is impossible to answer. And so my answer would be that there is no answer. In other words, there is no solution. No solution at all for this particular function. And because there's no solution, what that means is that there are also no x-intercepts, because the purpose of solving is to determine where these things are. So here there are no x-intercepts at all. Okay? So if I wanted to graph this function, I would have to find another way to get points. I can make a table, or I can solve it using other methods, get points using other methods. All right, number 4, the last one. So in this example, once again, we start the same way. So I will divide everything by 5. What I get is x squared is equal to positive 2. Now that positive number is looking good because that tells me I'm going to get an actual answer. I'm going to have an x-intercept, either 1 or 2 of them. But let's see what happens from this point. So I know that I need to square root both sides. And in doing so, these two cancel out. So I get just x by itself. Now I have a radical 2. This radical 2 is not a perfect square. And I need to simply bring it down because of that. I cannot do anything with this. I could put it into a calculator and it would give me about 1.4 something, 1.41, something like that. But I'm not going to do that. Okay, I'm going to leave this right there. And I'm simply going to represent this because I have an actual value that's not 0, but it's a positive value. That means automatically that I'm going to have 2 of them, one positive and one negative. And what this means is that, once again, I have 2 x-intercepts. However, the way to write them would be radical 2, comma 0, and negative radical 2, comma 0, right? Because you have to consider there's a positive value and a negative value. And each one represents a location along the x-axis where this graph would actually touch. Just as a side note, by the way, in case you're wondering, what is the square root of radical 2? As I said before, this is about 1.4. So if you did want to write this in decimal form, it would be plus minus 1.4. And I put that little wave right there because that means approximately 1.4, positive, negative. So with that in mind, you can also write 1.4, comma 0, and negative 1.4, comma 0. And those would be your 2 x-intercepts. So out of everything, when we look at all 4 of them side by side, the first one, example 1, would be the easiest one to plot. It's just 1 point, it's at the origin, easy. The second one, also pretty simple, because you have two very clean answers, 4 and -4, and those are easy to plot as well. This one, obviously, number 3, there is nothing to plot as far as x-intercepts are concerned, so that you have nothing to worry about there. And this last one, though, this might be a little more tricky to plot because you have to really dissect those spaces between the whole value. So between 1 and 2, or between -1 and -2. You have to really sort of slice it to know where 1.4 would be and where this would be. Okay, which is why most of the time you would not be asked to actually place an x-intercept at either of these kind of places when it's that kind of a weird decimal number. Most of the time you're going to get this, this, or this. But you need to also be aware, you have to understand what this means. And it does mean you have 2 actual x-intercepts. So what I'd like to do to wrap this up is I want to actually show you what each of these functions looks like so you can make those connections to the solving and the interpretation. So I went ahead and I went to Desmos.com. This is this really great free graphing website. It's open to the public. You pay nothing for it. And I went ahead and I made my functions. And this is the first one. That's y equals 3x squared. That would be this one over here. So as you can see, there's one x-intercept and it's at 0, 0. And when we go back and look at this, we can see, yes, indeed, it is at 0, 0 right there. Okay, 0, 0. You can see it. The second one is here. Now, if you zoom in a little bit, like I did just now, you can see I do indeed have an x-intercept there and one right there. And if you look at those numbers, it's 4 and -4. And that is indeed what we got over here. This is the second one, 4, 0, and -4, 0. Okay, so you can see that the graph does go through those 2 places. All right, number 3, the one with no solution and no x-intercepts. That one looks like this. So it seems like you can't even see it, and there's a reason. The reason you can't see it along the x-axis is because there are no x-intercepts, like we said. So where is this thing? Well, you have to either go down or we have to go up. So I'm going to go up and up and up and up, and you can see, whoa, this thing is hanging out way above the x-axis. In fact, the lowest point on it is at level 16 along the y-axis. And that makes total sense with what we have here, which says there are no x-intercepts. So don't bother looking there, you won't find it. The last one is this weird decimal place, okay? And I'm going to show you that right here. And again, if you're wondering where to go, there it is. I'm going to go down, and then you can see if I zoom in, there's -1.5, and there's +1.5, and you can see, oh, okay. Oh, look, there's my 1.4. Oops, there's my 1.41. It's about right there. See? And if I go on the left side of this thing, there you can see, look, -1.41 or something like that. But it's this weird crossing of the x-axis, and it would be really hard to sort of locate the exact place for it. So when you zoom out, it looks like it's at a more exact place, like at a corner of a square, but it actually is not. When you zoom in, you can see it's more precise and it's more sort of in between that area. So anyway, I hope this helped you to better understand how to solve these functions with radicals and what they actually look like, and just bridging those ideas together between x-intercepts and graphs. Thanks for watching. Bye-bye.